Good morning. I hope you all are doing well. Our topic for today is power, which is a scalar quantity. Now, by definition, power is defined as the rate of doing work. So, work divided by time, that is power. Right? Now, let's try to understand this formula. Supposing there is a table on which a chair needs to be placed. Right? So, the chair has to be placed on this table. I personally, supposing I take part in the experiment, I lift this chair up and I put it on top here. The time taken was, say, 5 seconds. Another person, B, okay, stronger, puts up this chair in a time of 2 seconds. The same chair has been put on the table in time 2 seconds, right? Now the work done by both of us is the same. Why? Because work is mgh, the weight of the chair multiplied by the height to which it has been raised. The work done is same, but the power is different. Why? Because of this time factor. I have taken a longer time, so whatever work has been done by me gets divided by 5. So the power developed is less. Okay? Whereas the second person did the same work in less time. So here, the work is being divided by a smaller time, 2 seconds. So the power developed is more. So power is the rate of doing work, or work divided by time. Now the unit for power is the unit of work divided by the unit of time, joules per second, which has been replaced with the name of a scientist, which is watt. So the SI unit for power is watt, written with a capital W. So this is the SI unit. Now we are also asked at times to define the unit of power. So in order to define the unit, okay, if you are ever asked to define the unit of power, so definition of 1 watt power. So if we are asked to define the unit of power, this formula helps us. Power is work divided by time. So to get an answer of 1 watt, okay, the work done should be 1 joule in time 1 second. So if 1 joule of work is done in time 1 second, or every second, then the power developed in the body is 1 watt. Okay? So this is how we define the unit of power. Then there's yet another unit. This is in the FPS system, which is horsepower. Now since horsepower is a different unit, it's in the British system, right? It has to have some kind of relation with the SI unit. So 1 horsepower, how it is related to watt is 746 watt. Right? And of course there are bigger units, kilowatts. The word kilo itself means 1000, so 1 kilowatt means 1000 watt. So this is the definition and the unit of power. Now if you look at the definition, work is involved in the definition of power. So all the expressions for work will also be involved in case of power. Now, let's write down the different expressions for power. Now first one, power is rate of doing work, so work divided by time. Then the second expression for power becomes, since work is involved here, if there is an angle between force and displacement, then F is cos theta, the general expression for work divided by time. This will be our second expression. The third expression for power, if force and displacement are in the same direction, so F into S divided by T. And the fourth expression for power is mgh divided by T. So altogether we see there are 4 expressions, right? Because work is getting involved. Now if you look at the expression here, the third one, since there is displacement upon time, right? If you just look at this part. Displacement upon time, rate of change in displacement is nothing but velocity. So we can also say power is force multiplied by velocity, or speed in a particular direction. Now this is one extra expression for power. So sometimes in ICSE we are even asked to write this expression of power in terms of speed. So power is force multiplied by speed, or force multiplied by velocity. So these are the various expressions which are required for solving the numericals. Thank you.